In 2023, over 2,000 wildfires burned a cumulative 2.84 million hectares across BC. Tens of thousands of people were forced from their homes, as many structures were lost entirely to the blaze. As the impacts of climate change creep ever closer to Kelowna, it is clear that we need to take action now. Our research shows that currently, 40% of wildfires are reported by the public. This figure is way too high, as ideally, fires would be detected by machines instead of using human input. Currently, the process of reporting a wildfire in BC is extremely long and complicated. Oftentimes, it'll take many hours before anyone is even alerted to the presence of a fire, leading to fires spreading out of control quickly.
Through group ideation, we decided to focus more on the detection of wildfires rather than stopping fires or preventing them. There are over 600,000 square kilometers of forest in BC, meaning that if we want to cover all that with sensors, it would take millions upon millions of dollars just to have that area covered. Not only would it be very expensive, but it would be very difficult to maintain all those sensors that were placed in forests. Clearly, it's not possible to have it good, fast, and cheap, but we've come up with an idea that could. Introducing the firefighting aerial reconnaissance technology.
So this aircraft has 3 degrees of freedom. We have yaw, roll, and pitch. So you can see on the wings here that we can control our roll using ailerons. So you can see the degrees of freedom there. And then moving back to the rudder, of course, we can move that slightly side to side as well. And then we have our elevator at the bottom that controls the pitch of the plane.
So you may be wondering how good our propeller game is. As you can see, we have a Turnigy aerodrive motor with 2-bladed propeller, almost 14-inch in diameter and made out of carbon plastic. The motor gives out a max thrust of 60 Newton while only weighing 160 grams, which is pretty good. And when combined with a 12,000 RPM and this huge propeller, this baby can fly.
As proving out low cost and ease of manufacturing was one of the key objectives of this proof of concept prototype, we elected to build the aircraft out of foam board material. The foam board was marked with a pencil before being cut with a hobby knife and ultimately glued together with hot glue. Using cheap materials and easy manufacturing methods such as this enables us to prove out that we can ultimately scale this approach up to a large fleet of vehicles.
Thanks to advances in modern technology, hobbyist drone components have become just as effective and a lot cheaper than their military-grade counterparts. For this vehicle, we're using a technique that we've seen in the Ukraine war, where militaries are creating drones smaller and cheaper than ever before, but in a much greater number. This allows us to produce the same amount of fire detection efficiency as existing aerial models, but over a much larger range and for a lot cheaper and with a lot more redundancy than existing systems.
We built a full-scale model of our aircraft for under $100 in new materials, as well as some donated parts from the Aerospace Club. Compared to the surveillance aircraft, a fleet of these would be incredibly cheap.
In order to detect forest fires, we use this Arduino module in a 3D printed case so that way we could insert it and take it out very easily, so that way we could read the detected data very quickly. What we do is we detect infrared readings using our infrared sensor, which locates that data with our GPS data here, reading it onto the SD card so that we can save it, all running through this power bank here so that way we can maintain power while in flight. Whenever our infrared module detects any infrared waves from any fire, such as this lighter here, this light over here turns on, and as well, we get data reading into our serial monitor here, which tracks the position, intensity, and the time of the fire.
And now, without further ado, the firefighting aerial reconnaissance technology.
In conclusion, this prototype was successful at demonstrating both the low-cost feasibility and the efficiency of this design. In a future production model, we would improve both the range as well as the infrared detection capabilities of the model. We believe that this is an amazing method for detecting wildfires and could help BC firefighters fight the fires that ravage BC every year.